are covering our first PO of the year. Here we go, PO4. Finding the greatest common factor of a set of numbers. And we're going to start by defining what factors are, because you've probably heard this phrase, greatest common factor, before. You've probably heard this phrase, least common multiple, before. And those two things are oftentimes swapped. They are misunderstood for one another. So let's start by defining what is a factor. Factors of a number, yeah.
It's something that goes into the number.
Okay, a number that goes into another number evenly. Okay? A number that goes into another number evenly. Is your computer open or is it closed?
Close.
Excellent. So for example, if I ask you the factors of 12, what are the factors of 12? What are numbers that go into 12 evenly? 6. And? 2, right? We would call 6 and 2 the factor buddy, or the factor pair, right? Because 6 times 2 is 12, 2 times 6 equals 12. Okay? Well, we'll see if I can make it more enjoyable for you. Do you know another pair of factors for 12? 1 and 12? And there's one other one.
4 and 3.
4 and 3. Okay? So all of those numbers go into 12 evenly, therefore they are the factors of 12. And I labeled them as I have to show that the factor buddies, right? 6 and 4 are both factors of 12, but they're not factor buddies, because 6 times 4 doesn't make 12. 6 times 2 does. Okay? And 4 and 3 and 4 and 12. So finding the greatest common factor, or the GCF, is as easy as 1, 2, 3, or FCG. Okay? As it turns out, what you're trying to do is actually explicitly listed in the title. Greatest common factor. Right? So we're going to talk about two methods to find this. The first one is the listing. This might be the one that those of you saying it takes forever, this might be the one that you've used in the past. Maybe not. Okay? But I've got a second one that typically goes a little bit faster. Kids typically like it a little bit more. But this one works just as well. Okay? F stands for factors. I should say list, not find. It's the listing method here. List the factors of each number. Just like we listed the factors for 12 there. Okay? You should write this down. Yes.
What does the middle one say?
List the factors of each number. Sorry, I will try and improve my handwriting. List the factors of each number. And then C stands for common. Okay? You need to identify the common factors in each list. What numbers show up in both lists? Those are the common ones, right? Common means to share or to both have. If you have something in common with another person, you have a characteristic or a style or whatever it is, a favorite food, right, that you share. And that's what we're looking for here, those common factors. And then G, mirror, mirror on the wall, which is the greatest of them all. The greatest of the common factors is the answer. We're looking for the GCF, the greatest common factor. So first, list the factors. What are common? And then which one is the greatest? That's it. Okay? Do you recognize this? Have you done this with this? Is this the one that takes forever? Those of you that were?
Yeah.
We just did the first one.
Okay. Yeah. Which can be tedious, especially if you're not really strong in your factors. Like if you have to list all the factors of 80, there's a lot of them. and you probably don't use 5 times 16 too often, right? So it's easy to miss factor pairs when you're listing them, because if you're not super strong in factors, it's easy to leave some out, okay? Which is why we also have the table method, right? The table method works like this. If we're looking for the GCF of 40 and 72, and leave some space because we'll also do the first method too. But just to show you this, we're going to start by making a table, and we've got two numbers. So our table is going to look like this, and we've got 40 and 72. I guess I kind of don't need to make this quite as long here, something like that. 40 and 72. Have you been shown this before? Yeah?
Yeah.
Oh, well, there you go then.
I don't remember.
Do you like this one more?
I don't know.
Can you show us?
Oh, yeah, I'll still show you it. But yeah, if you've seen it before. Okay. Okay. So then, those that remember, what do we do?
I just remember doing
No, it doesn't mean that you remember what to do, but if you've seen it before, does anyone remember what to do here? Okay, so the nice part about the table is that instead of knowing all the factors of 40 and all the factors of 72, you just need to know a number that goes into each of them. So what is a number that goes into both 40 and 72? 8 does. Okay? So we're going to put 8 up here, right? And then what do we do next? What do we do with that 8? Do we remember? Okay? So our next step is we're going to divide each number, 40 and 72, by 8. Right? And that gives us 5 here and 9 here. Okay? So then we take a look, we say, is there any common factor for 5 and 9? Is there any number that goes into both 5 and 9 evenly? No. Therefore, 8 is our answer. Our GCF is 8. So we didn't have to know all the factor pairs. You didn't need to know that 12 goes into 72 or 18 or 36. You just needed to know that 8 goes into each of them, divide, and then nothing else goes into both 5 and 9. You got your answer. Yeah.
So what if if we just put in plug in an answer and it's not right, do we just erase and just keep on doing it again?
If it's not the greatest common factor?
Yeah.
Let's explore that. Okay? Let's do the same thing again here. Only this time, let's not choose 8. What is another number that goes into both 40 and 72, but not 8? 9 doesn't go into 40. 2 does. Okay? And we know that because they're both even, right? If both the numbers are even, 2 is a great place to start because you know that 2 has to go into every even number. So we're going to divide by 2. What's half of 40? 20. What's half of 72? Not 31. 36. Okay? So now, instead of 5 and 9, like we're up here, we're saying what's a number that goes into both 20 and 36?
No, I'm wrong.
2 does again. They're both even. Okay? So we'll put a 2 here. We'll divide by 2 again. Divide by 2, divide by 2. We make another line here. What's half of 20? 10. What's half of 36? 18. Is there anything that goes into 10 and 18? 2 does. They're both even. So divide by 2, divide by 2. 10 divided by 2 is 5. 18 divided by 2 is
9.
oh, looky here. We've eventually gotten down to the same numbers in both tables.
Basically, you did all that for
No, Aiden, we never do anything in here for nothing. Right? If you didn't know that 8 went into 72 and 40, but you knew that because they're both even, 2 did. How do we get 8 as an answer here from our 3 2s? What's 2 times 2 times 2? 8. Right? You get the same answer either way. So we didn't do it for nothing. But if you don't pick the greatest common factor right off the bat, you'll still get there. It's just that you have to multiply all of these factors that you did pick in the very end, right? Maybe instead of 2 here, you said, oh, I know 4 goes into 20 and 36. 20 divided by 4 is 5. 36 divided by 4 is 9. 2 times 4 is 8. You'll still get there. Okay? So the point of doing this is to just remind you that there's no pressure in picking that largest factor right off the bat. All we did was we knew that 2 went into each of them, and we eventually got the answer. Now, is this longer than that? Sure, right? But does it take forever, like looking for those factor pair does from method 1? No. Some of you might like this one a little bit better. Okay? Yeah.
I know
Okay. Let's just run through method 1 here so you can see it with the listing method. The listing method would require us to list all the factors of 40. Give me a factor pair of 40. We're just gonna do it once. You know, it's good experience. It might encourage you to do this method here. 8 and 5. Good. What else?
8 and 9.
8 and 9 for 72.
Yay!
What else?
2 and 20.
2 and 20 for 40.
40 and 1.
40 and 1 for 40.
72 and 1.
72 and 1 for 72.
4 and 10.
4 and 10.
36 and 2.
36 and 2. 3 more for 72.
Oh,
6.
6
12. Good.
18 times 4.
18 and 4. One other one.
In chat.
Ooh.
Gotta get at least. Wait for 40.
72. We're 40. We've got all of them there.
Oh.
72. There's one other one.
Wait, what?
Harrison, we're on PO4 in your binder right now.
You did not.
And this is why the listing method can take forever, because it turns out we don't need this other factor pair. But what if you did? What if the factor pair you didn't know was the answer? It ends up being 3 and 24, which is moot because 8's the greatest common factor anyway, right? But this is why the listing method gets a bad rap, because if this had been the one we needed, who knows how long it would have taken to find it. That's why the table method, it's more structured, right? It doesn't require you to know all of the factors, okay? That kids tend to gravitate towards this. Enzo.
How is 8 the most common factor?
It's the greatest common factor. There's no other number. I mean, 2 shows up in each of them, but 8's greater than 2. 4 shows up in each of them. 8's greater than 4. 1 shows up in each of them. 8's greater than 1. There's no number greater than 8 that shows up in both lists. That's why 8 is the greatest common factor. Okay. 12, 30, and 60. Can we use the table method for 3 numbers?
Yes.
Yes, we can. Let's do it.
Can I do it?
12,
No.
30,
Whoa.
60.
Me, German.
I'm German. What is a common factor? What goes into 12, 30, and 60? Jillian, 6 does.
Oh, wow.
We'll do that in red.
6.
If we divide by 6, divide by 6, divide by 6.
2, 5, and
12 divided by 6 is 2. 30 divided by 6 is 5. And 60 divided by 6 is 10. So we're counting this. And then is there any number that goes into 2, 5, and 10? Hayden.
recording right now?
Yeah.
Yeah. See, I'm right. I didn't see the bar. I didn't see the bar at the bottom.
Oh,
Because
yeah,
I knew
yeah.
it just said.
Well, he's so
Is there any number that goes in both or all three, 2, 5, and 10? No. Therefore, we are done. And 6 is our greatest common factor.
Okay, we're not doing this.
That goes into 2, 5, and 10? Okay, so greatest common factor, that's the valid point. Greatest common factor only deals with integer values. So no decimals, fractions. Okay, only integer values. If you're doing the table method and we didn't pick 6,
Oh, I got this.
whoops, there we go. What number goes into 12, 30, and 60, but not 6? 2 does. They're all even, so let's just start with that one. Divide by 2, divide by 2, divide by 2. Half of 30 is 15. Half of 60 is 30. What goes into 6, 15, and 30? 3 does. Divide by 3, divide by 3, divide by 3. We get 2, 5, and 10. The same 2, 5, and 10 that we had up top there. But this time, because we have more than one number, we have to multiply 2 times 3, and that gives us 6 as our GCF, the same one we got before. Okay? Zeke, how are you feeling about the table method now?
I still don't like it.
Okay, I'll take
I'd rather
that.
have the graph thing.
The
Yeah.
graph thing. What's the graph thing?
Like the dot, not dots.
Quarter plane?
Yeah.
Oh, we can't do quarter plane with GCF. I mean, we'll get there eventually.
No, I like the coordinate plane.
But
That.
we will not be doing box numbers
Yeah.
five.
Yes.
You'll get it in Khan Academy. At
Oh,
some
you
point.
gotta be kidding me.
But,
It's so hard.
yeah. Well, maybe we should go over it. Maybe we should.
No.
No.
We didn't have 3 pages.
Maybe we should.
It's just there.
Numbers that don't have a GCF, just throwing this out there, numbers that don't have a GCF are considered relatively prime. If you can do a great British accent, that phrase sounds super cool. When you say a British accent, everybody have.
Do it.
I don't.
If you
I don't.
believe you
I'm
can
offering it. Let someone else shine.
If you believe you can cheat.
I don't believe though that I have a great British accent.
But I know I too, but there's
Matthew's got the floor. Matthew, go ahead.
Numbers are relatively prime.
Excellent. Why don't my buttons work anymore, people? This is so frustrating.
I identify as alien.
I don't know why.
Sea turtle in the Maldives.
I don't know why they're doing that. That is just so.
It's because
Do the air horn.
No, not the air horn. Anyone else have a great British accent? See if my buttons can work. Aiden.
Numbers that are relatively prime.
Good job. Anybody else?
Wait, last time I checked, you didn't do it.
Side. Oh, British.
Go for it.
Oh.
Numbers. No.
Numbers are relatively.
Go, Jenny, go.
I don't practice my British accent. You look like
Yes,
Jillian, are you?
Always my
No, okay.
So you give
Shy, I will
Yeah,
give it a shot.
without Great Britain, we wouldn't be a country.
Numbers that are relatively prime. Okay, but it is possible for numbers 8 not to have a GCF, and if that's the case, then they are called relatively prime. They're not prime numbers, but they're prime relative to each other. That when you compare them, because they have no GCF other than 1, I should say, it is technically 1 because 1 goes in everything. But they are prime relative to each other. They don't share any factors other than 1. So your homework for Monday is to just this second page, these 8 here, finding the GCF of the numbers. You can use either method you want. Jillian, if you like the listing method, you can use it. If you like the table method, you can use it. However, work must be shown. Harrison? Okay, work must be shown. So, is there one you'd like to do together? in the 10 minutes that we have left, just because.
Not all of them.
Not all. We won't have time for all of them. Aiden.
27, 81, and 150.
Is that the bottom row? Okay.
Yes, sir.
Let's use the table method for this, just because. And we've got three numbers here, so we need 27, 81, and 150. Okay. What is a common factor? It doesn't have to be the greatest common factor. What's just a common factor? H, too much chatter over here. Common factor of 27, 81, and 150. What goes into all three of those? Amelia. 9. Okay. 27 divided by 9 is 3. Oops, I'm gonna write that in 3. 81 divided by 9. 150 divided by 9. What's 81 divided by 9? 9. What's 150 divided by 9?
I don't know.
It's like 12.
Does it not?
Well, being like 12 is not good enough for UCF. Turns out 9 does not go into 150. Okay? So,
Oh, I got it. I think so.
Wait, 9 doesn't go
no,
3.
9 does not go into 150.
Trace.
So, when you
Trace.
miss the number, you just gotta start over again.
Why did you say Spanish?
I don't know. I almost failed Spanish.
Are you drinking right now?
I don't have. I
3, 2, 1, you are quiet. Thank you. Matthew threw out 3. So divide by 3, divide by 3, divide by 3. 27 divided by 3 is 9. 81 divided by 3.
9.
Oh,
No,
27.
7.
150 divided by 3.
50.
50.
50.
Wait a minute. Just a little bit off.
And is there a number that goes into 9, 27, and 50?
No.
There is not. Therefore, what is our GCF?
3.
It is 3. Okay? So this is a situation where definitely the table method is more efficient because you don't have to list all the factors of all 3 numbers. However, make sure that when you pick a number, it actually does go into all 3 of them. Okay? You will be able to use a calculator on this part of the test. So you will have that advantage when trying to decide what goes into numbers and things like that. This is due on Monday. Tomorrow is a retake day. Aiden, just hold your horses, man. Tomorrow is a retake day, which means that your retakes from your entrance exam, it's your opportunity to work on them. If you need practice work, write that down, post a note, give it to me, and I'll print it off for you. Otherwise, it was emailed home over the summer, so your parents may still have it. Khan Academy is due tonight. Math packet is due next Tuesday. Tomorrow is the last day to turn in your packet early for me to check over before it is due on Tuesday. So yes, Aiden, the homework is just this page. Don't go on to page 10. Page 9 is your only homework due on Monday. Lucy. Yes, if you give me the practice work tomorrow during class, that's just fine. That'll work. Any other questions, comments, concerns, complaints, comments, congratulations, or criticisms? Don't push your binder away. You got 5 quality minutes to work right now. We're out at 8:30.
I'm thinking math schedule.
8:30.
I'm on
Liv.
Wait, can we do our practice work at home?
Yes, practice work can be done at home. Retakes must be done here, though. Enzo, can you have a seat, please? I'm not quite done teaching yet. James.
You should get a real headset.
Why?
Agree.
Cause it'd be more style.
Oh. Are they expensive?
No,
Yeah.
some of them are only
I have an extra one for you.
Well, it'll mess up my hair, though.
Your hair's.
What?
You don't even have hair.
I'm gonna be real.
Who said that? Harrison, you did a really dog.
That's not
true.
You can literally see it on its head.
Yes.
I'll give you a
When I said what hair?
screenshot for that.
Yeah, your hair. I don't look at you.
No, not necessarily.
Yeah,
Just
not a
if
day,
you,
it's
if you
25 years.
throw shade at me,
Matthew, you
then
can't
don't be
just
upset
say
when I
that
throw
out
shade
loud.
back.
So why can't I?
So, it might not be
George
immediate.
Washington fought for freedom of speech.
Matthew, can you turn around, please? Thank you. Lucy,
Why do you say my name like that?
how would you like me to say it?
So like.
Say it like
Okay,
emo
I'll
voice.
do that.
You want me to accent the Lucy?
Say it in the emo voice.
Okay.
What do you want me to? What do you
No,
want
I
me to
just
say?
wanna
What
tell
do
you
you want me to say?
I mean,
Oh.
so you know how to get you to 500 subscribers, you have to give us donuts.
Right, yes.
Did you
We give you
mean?
the 550. Well, can you start a gaming channel?
550?
Yes.
I don't know how that gaming stuff, I don't know how to put it on
He
there.
did streamer. Twitch streamer.
Can you
Chat.
get
Do I have the headset for it?
No.
What's
You
could do in the day?
Alright. Let's do the outro, then you can do work, we can do that. That's our man.